Hey guys, welcome to this tutorial on the convolution examples. I'm sure you're super excited to see these examples like this guy. Just kidding, I know convolution is a complicated topic and sometimes scary for students, but here's what I promise. By the end of this tutorial, you would have no problem with convolution anymore and you would be able to solve any example quickly. So let's start. As I said last session, convolution is usually shown by the star sign. There are two ways to present convolution. The first way is the one that I explained last session, integral from minus infinity to infinity x tau ht minus tau d tau. The second way is the integral of h tau xt minus tau. It's basically the other way around. Please note, both forms are equal. In fact, it doesn't matter if you choose one or two, you will get the same final answer. As I don't want you to memorize anything, let me show why they are equal. Here's what I'm gonna do. I want to tweak the second integral to create the first one. Let's change the variable. I want to replace t minus tau by k. The integral variable is tau, so you can treat t as a constant. Let's apply derivative here. T is gone because it's constant. Here's what we get. Minus d tau equal to dk. Move the minus sign to the other side. Now, when we change the integral variable, we also need to change the interval. When tau is minus infinity, we get t minus minus infinity. We can ignore t and therefore k becomes plus infinity. Let's do the same calculation for the upper bound. When tau is plus infinity, we get t minus infinity. Again, you can ignore t and we end up with k equal to minus infinity. Also, let's write this equation in this form. Now, to change the variable from tau to k, we need to replace all these things here. Lower bound is replaced by plus infinity and the upper bound is minus infinity. Tau becomes t minus k and t minus tau becomes k. Finally, d tau becomes minus dk. Let's bring the minus sign out and write it again. Now, look at this guy. As you know from calculus, negative sign multiplied by integral from b to a is equal to integral from a to b. In fact, we can use the minus sign to swap lower bound with the upper bound. So let's apply it and swap the interval here. Here's what we get. Now you can change the variable name by whatever name you want. It doesn't really matter if the name is k, tau, z, whatever. It's just a name. So I'm gonna replace k by tau. By changing the name, we end up with this integral, which is exactly similar to form number 1. So we prove that both forms are equivalent. Sometimes the first integral is a little bit simpler than the second one or the other way around. Now let me explain a systematic approach that you can easily follow to find the convolution. Step number 1. Find critical point in each signal. I call a point critical if the function is different before and after that point. For instance, if we have this signal, this is a critical point because before that the function is 0 and after that it's 1. Or this is a critical point because before that the function is 1 and after that it's 0. Another example, the line equation between minus 1 and 1 is t. This is a critical point because the function before that is 0 but after that it's t. Or here is a critical point because before that the function is t and after that it's 0. Please note that this is not a critical point because before and after that the line equation is the same. One more example to make sure you got it. We have a sinusoidal function in this interval. These are critical points because before and after them the function is different. But this one is not a critical point because before and after that the function is still sinusoidal. Step number 2. Plot x tau and ht minus tau or the other way around. Obviously, if you choose this integral, you should plot x tau and ht minus tau. And if you choose this integral, you should plot h tau and xt minus tau. Step number 3. Compare the critical points in both signals and find different scenarios. Last step, for each scenario, form the integral. Let me recap all the steps. First, find critical points. Next, plot the corresponding signals based on the integral you choose. Then, compare the critical points and find scenarios. Finally, for each scenario, find the integral. That's it. First example. xt is a window which is 1 between 2 and 3, and ht is a unit step function. And the question is, what is the convolution between x and h? Basically, this is xt and this is ht. Step number 1. Find the critical points. For xt, 2 and 3 are critical points, and for ht, 0 is a critical point. We have 2 critical points here and 1 critical point here. As we have less critical points here, I prefer to go with this integral. Step number 2. I need to plot these functions. To plot x of tau, we just need to replace the variable t by tau. The shape is exactly the same. Now let's plot this function. You can rewrite this as h minus tau plus t. The order doesn't really matter. You can write 1 plus 2 as 2 plus 1. The integral variable is tau. That's why I prefer to see tau at the beginning. It's less confusing for me to plot the signal when the variable comes first. Here h is a function of t, so the first step is to replace t by tau. Then we need to apply this time shift. Because we have a plus sign here, we shift it to the left. So 0 goes to minus t. Here's what we get. If you have no idea what I'm talking about, please watch my tutorial on signal transformations before you continue. Then we need to apply time scaling by -1. Again, as we learned in signal transformations tutorial, all we need to do is to reflect the signal with respect to the y-axis. So minus t goes to t. Here is what we get. I'm gonna change the order again to make it consistent with the integral. Let me plot it one more time because I want to see it under x of tau, and I'm gonna delete all this stuff as I don't need them anymore. Okay, third step. Compare the critical points and find scenarios. These are the critical points again. First scenario, when t is less than 2. The product between x and h signals is always 0 in this case, because the non-zero part here is multiplied by 0, and the non-zero part here is multiplied by 0, so we get 0 everywhere. Integral means summation. Summation of lots of 0 is still 0. Let's consider another scenario, when t is between 2 and 3. So if we plot it again, this critical point is between 2 and 3. In this case, this non-zero part is multiplied by 0 here, so the product is 0. Also, h is 0 for all the points beyond t. Therefore, here is the only box that the product between x and h is non-zero. So, the integral is non-zero from 2 to t. In this window, x is 1 and h is 1. So the product is 1. Here we go. The last scenario that we can consider is when t is greater than 3. Let me plot h again for this scenario. This non-zero part from -infinity to 2 is multiplied by 0 here. Also, x is 0 for all the points beyond 3. So here is the only box that the product between x and h is non-zero. Therefore, the integral is non-zero from 2 to 3. In this interval, both functions are 1. Okay, here's what we get. Let's simplify these two integrals. As we know from calculus, this definite integral is equal to t from a to b. To get a closed form answer, we replace t by upper and lower bounds and subtract them. So the integral is equal to b minus a, or upper bound minus lower bound. Accordingly, this integral is equal to t minus 2, and this integral is 3 minus 2. Let me write the final answer again. Yt is 0 for t less than 2, t minus 2 for this window, and 1 for t greater than 3. Done. Next example. xt is e to the power of minus t multiplied by ut, and ht is 1 between 0 and 1 and 0 otherwise. Again, our goal is to find a convolution between x and h. First, let me plot xt. The exponential function is like this, which is non-zero from -infinity to +infinity. Ut, or unit step function, is 0 for t less than 0 and 1 after that. So the product between these two functions is like this. Let me plot it again. This is our xt, and this function is e to the power of minus t. Also, this is our ht. Okay, now let's find the convolution. Step number 1. Find the critical points. There is one critical point here and two critical points here. As we have less critical points for xt, I prefer to go with this integral. Step number 2. We need to plot these functions. H of t is already given. To plot h tau, just we need to replace t by tau. That's it. The shape is exactly the same. To plot the second signal, let me write it in this form. I'm just changing the order as tau is the integral variable and I prefer to see it at the beginning. To plot this signal, we need to replace t by tau. Here we go. Then we need to apply time shift by shifting the signal to the left. Finally, we apply time scaling by reflecting the signal with respect to the y-axis. Minus t goes to t. Let me change the order again to be consistent with the integral and plot it under h of tau. We don't need all this stuff anymore. These are critical points. Oh, before I forget, for x of tau, this function is e to the power of minus tau. Now, when we transform x tau to this new form, basically we are replacing tau by t minus tau. So you need to apply the same transformation here. Simply replace tau by t minus tau. That's it. Step number 3. Compare the critical points and find scenarios. The first scenario is already plotted here when this critical point is greater than this critical point, i.e. when t is greater than 1. For this case, 0 in this interval is multiplied by this tail. Also, h is 0 for all these points. So here is the only box that the product between h and x is non-zero. So the integral is from 0 to 1. In this interval, h is 1 and x is the exponential function. The second scenario is when t is between 0 and 1. Let me plot this scenario. Again, t is between 0 and 1. For this case, the tail here is multiplied by 0 and all the points beyond t are 0. Therefore, between 0 and t is the only place that the product of x and h is non-zero. The integral is from 0 to t. H is 1 and x is exponential function in this interval. Last scenario is when t is less than 0. Let me plot this scenario. In this case, the whole exponential function is multiplied by 0 here. Also beyond t, x is 0 all the time. So the product by h is always 0. Now it's time to simplify the answer by finding the integrals. Yt is 0 for t less than 0. I'm gonna break the exponential function into two exponential functions like this. The same story for the next integral. Now look at this integral. The variable here is tau. The first exponential term is a function of t and has nothing to do with tau. So you can treat it as a constant and bring it out. The same story here. Let me write yt again. I'm bringing e to the power of minus t out. Now from calculus, we know the integral of et is equal to et. Then to find this definite integral, we need to replace t by the upper and lower bounds and subtract them. Here we go. Let's simplify the integrals. Based on this formula, the closed form answer to this integral becomes this, and the same story for the second integral. E to the power of 0 is 1. Let's multiply e to the power of minus t by the parentheses and simplify the final answer. Here is the final answer for different intervals. Done. Next example. xt has two parts. For t less than 0, it's et, and for t greater than 0, it's e minus t. ht is a window and we want to find a convolution between x and h. First step, find the critical points. There is one here and two here. xt has less critical points, but you know it has two different exponential functions. H is a simple window and you can easily plot ht minus tau. That's why I prefer to go with this integral. I just want to emphasize that it doesn't really matter which format you choose. the final answer is always the same. It's just a matter of personal preference. First, let's plot x tau. All we need is to replace all t's by tau. The shape is the same. Here's what we get. Now let's plot this signal. I'm gonna write it as h minus tau plus t, because for plotting the signal I prefer to see the variable tau first. Let's replace t by tau here, then apply the time shift. -1 goes to minus t minus 1 and 0 goes to minus t. Here's our window. Finally, do time scaling by reflecting the signal with respect to the y-axis. So minus t goes to t and minus t minus 1 goes to t plus 1. Here we go. I'm gonna plot it under x tau again and write it as ht minus tau to be consistent with the integral. Let me clean all this stuff as I don't need them anymore. Again, there is one critical point here and two here. Step number 3. Compare the critical points and find scenarios. First scenario is already plotted when t is greater than 0. For this scenario, this is the only box that the product between x and h is non-zero. Before t and after t plus 1, h is always 0, so the integral is non-zero from t to t plus 1. In this interval, x is e to the power of minus tau and h is 1. The second scenario is when t is less than 0 and at the same time t plus 1 is greater than 0, which means t is greater than minus 1. So for this case, t is less than 0 and greater than minus 1. Let me write it here and plot this scenario. Before t and after t plus 1, h is 0, and consequently the product between x and h is 0 everywhere except this box. But look at this box carefully. This part is multiplied by e tau and this part is multiplied by e minus tau. So we have two integrals. The first one is from t to 0 where x is e tau and h is 1, plus the second integral from 0 to t plus 1 where x is e minus tau. The last scenario is when this critical point is less than 0. T plus 1 is less than 0, which means t is less than minus 1. Let me plot this scenario. T plus 1 is less than 0. Again, the product before and after the box is 0. The integral is non-zero from t to t plus 1, where x is e tau and h is 1. Here we go. As we know from calculus, the integral of e to the power of ct, where c is a constant number, is 1 divided by c. E to the power of ct from a to b. To find this definite integral, we need to substitute t by upper and lower bounds and subtract them. Here's what we get. In the first integral, c is 1, so based on this, we get et plus 1 minus et for t less than minus 1. Here, c is 1 again, and we get this by replacing tau by upper and lower bounds. For this integral, c is minus 1, and therefore there is a negative sign at the beginning. Here is what we get if we replace tau by upper and lower bounds. Finally, for the last integral, c is minus 1 too. Here's the answer. This is 1, and also this is 1. Let me write the final answer in a clean form. For this part, 1 minus minus 1 becomes 2, so we can write it like this. For the last part, let's multiply the negative sign by the parentheses. Here's the final answer for the convolution. Done. Last example. xt is sine pi t between 0 and 2, ht is a window, and we want to find a convolution. First step, find the critical points. There are two critical points here. Please note one is not a critical point as the function is still sinusoidal before and after that. Also, there are two critical points here. I prefer to go with this integral as h is a simple box and we can easily plot ht minus tau. To plot x tau, we need to replace all t's by tau. The shape is exactly the same. Let's plot the second signal. As the variable is tau, for plotting the signal, I prefer to write it in this form. First, let me replace t by tau. Then I'm gonna apply time shift. 0 goes to minus t and 3 goes to minus t plus 3. Here is our shifted window. Now let's apply time scaling by reflecting the signal with respect to the y-axis. Minus t plus 3 goes to t minus 3, and minus t goes to t. Here is our window. Again, let me mark the critical points. These two and these two. Step number 3. Let's compare the critical points and find scenarios. First scenario is when this critical point is less than this critical point, i.e. t is less than 0. Let me plot this scenario under x and I'm gonna erase all this. When t is less than 0, this window is multiplied by 0. Also after t, h is always 0, so the product between x and h is always 0. The second scenario is when t is greater than 0 and less than 2. Let me plot this scenario. This part is multiplied by 0. This is the only box where the product between x and h is not 0. The integral is non-zero from 0 to t. In this interval, x is a sinusoidal function and h is 1. Another scenario is when t is greater than 2, but t minus 3 is less than 0, i.e. t is less than 3. This means t is between 2 and 3. Let me erase this and plot this scenario. T minus 3 is less than 0 and t is greater than 2. This small part and this part, which is beyond 2, are multiplied by 0. This is the only box where the product is non-zero. So the integral is from 0 to 2. X is a sinusoidal function and h is 1. Next scenario is when t minus 3 is greater than 0 but less than 2. This means t is between 3 and 5. Let me write it here and plot the scenario. Whatever is beyond 2 is multiplied by 0. This is the only box where the product between x and h is not 0. The box is from t minus 3 to 2, so is the integral. X is sinusoidal and h is 1 in this interval. Last scenario, as you can guess, is when t minus 3 is greater than 2, which means t is greater than 5. Let me plot this scenario. As you can see, the product is always 0. Here we go. Now I want to find the integrals and simplify the answer. From calculus, we know the integral of sinusoidal function is minus 1 divided by c cosine ct, where c is a constant number. Then, to find the definite integral, we need to replace t by the upper and lower bounds and subtract them. Let's use this and find a closed form answer for the integrals. For t less than 0, it's 0. For this integral, if we want to use this formula, this is c, this is a, and this is b. So when t is between 0 and 2, the integral becomes this. For this integral, this is c, this is a, and this is b. So the closed form answer to this integral is this. For the last integral, again, this is c, a, and b, and here's the answer. For t greater than 5, the convolution is 0. Cosine 0 is 1, and cosine 2 pi is 1. Let me write the final answer in a clean form. 0 for t less than 0. Bring this coefficient inside the parentheses. Here's what we get. Also cosine 2 pi is 1. So 1 minus 1, we get 0 when t is between 2 and 3. And this is the answer when t is between 3 and 5, and finally 0 when t is greater than 5. Done. Before I let you go, let me explain one more thing which is crucial for the rest of this course. Convolution with a delta function which is shifted by t0. T0 is a constant value, for example 1, 2, whatever. When we convolve a signal with this delta function, we get the same signal which is shifted by t0. This is very important, so please pay attention carefully. As you can see, we have the same time shift here and here. Let me prove it. As I already explained, to find a convolution between x and h, we need to find this integral. This signal is our ht function. To find h tau, we need to replace t by tau, multiplied by x signal. The integral variable is tau. this delta function is only non-zero at tau equal to t0. So based on shifting property, the final answer is xt minus t0. If you don't know what shifting property is, please watch my tutorial on elementary signals. So let me write this again. xt convolved with delta t minus t0 is equal to xt minus t0. First example, xt convolved by delta t minus 2. t0 here is 2, so the answer is xt minus 2. Next example, ut convolved by delta t minus 1 plus delta t plus 1. t0 here is 1 and here is minus 1. So the answer is ut minus 1 plus ut plus 1. Okay, that's it for this tutorial. Thanks a lot for giving me your time and watching this video. Please don't forget to subscribe and see you guys in the next video.